midterm, we had a big unit on similar triangles where we set up proportions. All right, we set up a ton of proportions. I don't need you guys to have this down, but we set up a proportion, right? A over B, C over D. We cross multiply. But if you remember, there's specific names to the proportion. All right, whatever we put here for A and D, we called the extremes, and whatever we put here for B and C, we called our means. What we're going to work with today, tomorrow, special type of proportion, a special one, where what we put in for the means will be the same. All right? You will see all proportions we set up today, the means will be the same exact number or variable, and my extremes will be different. When the means are the same, we call this a mean proportional. All right, that's what I refer to it as. All right, a mean proportion. All right, when the means are the same. So that's what I'm going to ask you to set up here in this first example. Give me a mean proportion between 4 and 16. I'm asking for a proportion, since it says mean proportion, where the means are the same. So we can put any variable you want there. The means will be the same in this proportion, but the other extremes are 16 and 14. Or 16 and 4, sorry. Means are the same in a mean proportion. That's what I'm looking for. If your numbers are 16 and 4 for your extremes, give me two numbers that multiply to the same thing that are the same. So cross multiply, I get x squared equal to, bust those calculators out. All right, one thing I'm going to do differently is making sure you're doing the work and I'm just not throwing it up here for you. Because that might be part of the problem. So you have x squared equal to 64, I hope. And then taking the square root on both sides. So our means here for this mean proportion will be, yeah, you can put 8 there, but we're missing something. Yeah, 8 times 8 is the same as 16 times 4, but another number as well. We're missing here. Just took the square root of a number. Not just 8. Not just 8. Not just 8. Not just 8. 8 times 8 does give you 16 times 4, I agree. But so does negative 8, right? Once you take the square root of a number, you get the plus and minus version, right? Negative 8 times negative 8 is 64. So 16 times 4. So this is what we're going to be setting up today. Mean proportions. Means are the same, extremes are different. Now in this problem, we took the plus and minus version. Sometimes I only want the positive version though, and you'll see why later on today. I only want the positive version. So if I only want the positive version, I don't want the negative version, only the positive version, we're going to call that a geometric mean, the positive version of this. All right, the positive version. So give me a geometric mean of 15 and 20. What number multiplied by itself will give me the same result as 15 times 20? All right, so here we go. And my means are the same. I'm going to call them y's now. When my extremes now will be 15 and 20. Mean, geometric mean, I only want the positive version. And you can see in my directions, leave it in simplest radical form. So here we go. Crunch away here. Use your calculators. Y squared. Hopefully you're getting 300 when you do 15 times 20. And you guys don't know how lucky you are with those calculators, since it gives you simplest radical form already. And here we go, going right to the numbers here. What is that number in simplest radical form here? Shoom, Dylan? 10 radical 3, good. And again, only putting the positive version. Geometric mean is the positive version of this. Usually, yeah, I would put plus or minus 10 radical 3, but it asks for the geometric mean. All right, questions? All right, I'm showing you this because those are the type of proportions we're going to set up today and tomorrow. I want to go back to similar triangles with you from before the midterm, similar triangles. So can you get this diagram going here? A, B, C. For a solid portion of this unit, anything I show you can only be done in a right triangle, including today's discussion. All right, a lot of the things I'm going to show you in this unit can only be done in a right triangle. Also, in this diagram, I'd like you from vertex B to draw an altitude to AC. Do we remember what that word meant? So from vertex B, from the right angle, draw an altitude to AC, please. From vertex B, draw an altitude to AC. What else did you put on your diagram? If it's an altitude, right angles, right? Altitudes form right angles. So I should have a right angle here and here. And where it meets on AC, let's put a D there. Let's put a D. Point D. Hey, how many triangles did we just form here? How many triangles are in your diagram? How many triangles? How many we count here? 3. 1, 2, and the big dog. I'll do triangle 3. All right. During our similar triangles unit, we had three ways to prove triangles similar. We really only used one way in a proof, and what was that way? Anybody remember that one? Angle. Yep, we used angle. So keep that in mind here as I ask these questions. Look at triangle 3, the big one, and triangle 1. Focus on those two right now. Triangle 3 and the big one. They both have what type of angle in them? Triangle 3, my big one, and triangle 1. They both have what type of angle in them? Right angle, and we know right angles are congruent. And they both share an angle. What angle do they both share? Triangle 3 and triangle 1. Angle A. Everyone agree? They got a right angle. They both have right angles, and they share angle A. So that means they're what to each other? Similar. All right. So we got triangle 1 similar to triangle 3. All right, let's keep rolling. Look at triangle 2 in the big one. Triangle 2 in my large triangle. They both have what type of angle in them? Right angle. Right angles are congruent. But now those two share what angle instead? Angle C. So we could say, hey, what about angle 2 and triangle 2 and triangle 3? They are also by angle. We're getting somewhere here. Triangle 2 similar to triangle 3. Got it. Look at what we just wrote there. Triangle 1 similar to 3. 2 similar to 3. So what do you got to know about 1 and 2 then? They're similar because they're similar to the same triangle. Yeah, 3. So what did we just discover? All 3 triangles are similar. Which leads me to our next point. If the triangles are similar, what do I know about their corresponding sides? They're in proportion, right? They're in proportion. Here's where it's going to get crazy now. Even the studs in this class might have a little trouble with this. All right, everyone take triangle 2 right now. All right, triangle 2. And I want you to look at side BC in triangle 2. What would that side match up with in triangle 1? Side BC in triangle 2, what would it match up with in triangle 1? And this is, if you're having difficulty, I'm glad you are. All right, wait, triangle 2, there's BC. Well, some of you might know what it is. All right, some of you might, but some of you might be struggling. All right, and it's okay if you're struggling. That's what today and tomorrow is about. I have two devices that are going to help you match up the sides in all these triangles. 2 devices. Let me introduce the first device, called Hills. It's called Hills. H over L equals L over S, hills. Wait, there's an I in hills. All right, relax. Sorry. I don't have anything that has an I that starts with the letter I. So that's how I spelled hills for this, all right? HLLS, hills. How does this help me match up the sides? Here we go. The H in hills stands for hypotenuse. And I know this is all up here for you. Hypotenuse. Go back up to my diagram. Hypotenuse of the large right triangle you originally created. So I'm going to ask somebody right now, name the segment up there that is considered the hypotenuse here. When we say H, it's the hypotenuse of the large right triangle. So which segment up here, because you got a bunch, would represent your hypotenuse? Woo! 3 here. Stellan, which one would be my hypotenuse then? AC. Good. So there's the hypotenuse, everyone, we're referring to in hills. L. The L in hills, or at least this L. Leg. Leg. That is the other side, the other two sides of your right triangle. All right, the other two sides. So Stellan already identified the hypotenuse. Where are your legs here? Where are the legs? Twos. Simon, not here. Simon, going. There he is. Everyone's got different seats now. Go ahead, one more time.
AB and BC.
There you go. AB is a leg. Come on, what's going on here? Won't let me write on there. All right, leg. What's going on? There we go. Leg. You ready? What about this L? Is that the other leg or the same leg? These are the means, aren't they? What did we just work on the first thing this morning? Means stay the same in a mean proportion, and that's what you're setting up. So these legs are the same leg. Whatever you put in for this leg is the same as you put in for that leg. Same leg in hills. Everyone good? Same leg. Always the same values for the means. And then S, finally, the S stands for segment. All right, let's go back up to my diagram. When you guys drew in your original right triangle, remember I asked you to draw that altitude in for me? And the altitude created not one, but 2 segments on your hypotenuse. That's where they are. So segment, segment. Well, which one do I use then, right? Which one do you pick? Because you only have one S there. Which one do you pick? Ready? The one next to the leg being used. All right? I pick the segment that is next to, adjacent to the leg being used. So let me get you a little scenario and I'll call on somebody. Let's say I'm using leg BC in my proportion. Leg BC. Which segment would I then put in? I'm using leg BC in hills. What segment would I put in then? AD or DC if I'm using leg BC in my proportion. Which one's going in there? 10. Henry, which one's going in? DC. Good. The one next to BC. We good on hills. Hypotenuse, same leg, segment next to the leg. All good on hills. Well, bad news. I may not have enough information to use hills. So there's a second device I told you. That second device, SAS. S-A-A-S. SAS will also help you match up the sides. Whew! All right, what about that S in SAS? Wild guess what that stands for. Segment. A for, well, it's the one thing we haven't talked about yet. Oh boy, we're going to pretend I didn't hear that. Altitude. Altitude, right? That's the altitude to the hypotenuse, right? Altitude. What do you think this A stands for? Same one or different one? There's only one in the diagram, right? And also remember, these are your means. Always have to be the same. All right, these are your means, so it's got to be the same altitude, and there's only one in the diagram. All right, think about this now. Dig deep and think about it. Everything we talked about this morning. This S, you know it stands for segment. Same one or different one? Darn right, different, because these are your extremes. So in SAS, we use both segments. All right, we use both segments in SAS. The only thing that stays the same are my means. Questions with those two devices before we start getting right into it. We're going to rip it right off now. All right, here you go. Buckle up. Okay, before we get proportion crazy, look at that diagram right now. And I want to make this clear. You cannot just throw out SAS and hills anytime you want or anytime you get desperate. You have to have a certain diagram to use hills and SAS. Everyone see the big triangle, ABC. What type of triangle is it? Right triangle. It's a right triangle. And what is BD? That's called a what? What is line segment BD called? Altitude. That is the only type of diagram we can use hills and SAS with. It's a right triangle with an altitude to the hypotenuse. That's it. That's the only type we can use hills and SAS on. All good. All right, last job. Which one do you use? Is it a hills problem? Is it a SAS problem? You are not going to guess either and pray that you are correct. Here's how you determine which one of the two you use. You ask yourself this question: is the altitude involved? All right, look at the altitude BD. Do I have a length or a variable on it? I do not. So you cannot use SAS. You do not have enough information to use SAS because that deals with the altitude. All right, so that is the question you ask yourself. Is the altitude labeled? If it's not, like this case, we got a hills. If it is, we can use SAS. All right, so I can't use the altitude, so I got to use hills. All right, here we go. Help me fill it in. H for hypotenuse. How long is the hypotenuse in this diagram? How long is the hypotenuse? So I can fill that in. Whew. Here we go. Ones. Micaiah, what do you got back there? 12. Darn right. AC is 12. L for leg. I know, I got two of them. You only use the one that's being involved in the problem, right? Give me the leg I want to use here. Leg. Dylan. Y. Correct. All right, what about this L in hills now? This L. What am I going to put for that L? 4. Here we go. All over the darn place. I'll get it here. Test. There we go. Also Y. Yeah. Means are the same. No discussion. Means are the same. Now here's where you might have a little issue. Being the first time doing this. What segment do I use? The 9 or the 3? Remember what we talked about. What segment you want to use in hills. Do I use the 9 or the 3 here? Which one we going with here? Simon? 9. Segment adjacent next to the leg we're being used. All right, good. And it's going to be a rookie mistake at first. If I'm using this leg, I want to use the segment next to it. So that's why I'm plugging in the 3 and not the 9. That's hills right there. Questions? All right, now you solve. Y squared equals 36. Yep, square root that sucker. Now, I know we talked at the first problem we did today was a plus or minus one, but I don't want the minus here because I got a diagram. I want the geometric mean out. All right, I want the geometric mean because I cannot have a negative side length. So that side is 6. These devices help you match up the sides. All right, one more and then you're on your own. Altitude involved on this one? Altitude involved? Yeah, it's labeled X. I got to find it. So it's automatic SAS. Even if you tried hills, the X wouldn't come into play. All right, first S, segment. What do you want to plug in for that one? Shoo, Stephanie. That you're giving me the hypotenuse. Where are you doing SAS? S for segment. S for segment. 4 or 12. All right, either one would have been fine. 4 or 12. Here we go. Over A for altitude. What's the altitude labeled here? Cormac, relax. I got it. X. What about this A in the top right? That's going to be Brendan. Also X, altitude. There's only one in the diagram, and your means have to be the same. And what about the other S here in SAS? Other S, 7. We'll get to that one here eventually. 7, anybody? There we go. Drew? 12, the other segment. Got extremes have to be different. And if it doesn't say, you can leave your answer in simplest radical form. And when you have that simplest radical form, let me know. I want you guys to start using those calculators as much as possible. Back to you, Cormac. 4 radical 3. Yep. That next batch of 6, go ahead. You can do them on your own. You can do them together. I'm going to come around and making sure we're on the right path. You can work with your new group mates or try them on your own. Your call. But I'm going to have 6 people help me out on these. All right, here's what I'm going to do. I'm going to call on 6 different people. 6 different people. Need the proportion you set up, final answer. Okay, proportion you set up, and final answer. All right, so let's start with letter A. Give me your proportion and final answer here. Proportion, final answer. Here we go. 1, Micaiah, go ahead. What do you got for me? Good. This should have been a SAS question, and you got x equal to 9. Yep. Good job. Any issues? Ask away here if there is, or I'm just going to keep going. B. Had to do a little addition subtraction before we started here. Brendan, what do you got for your proportion?
50 over x equals x over 40.
Okay. 50 is the hypotenuse, though. Looks like you're using SAS on me here. I'll stick the 40 there. I don't want 50 for the other segment. Here's your other segment.
10.
10. I want 10, right? Okay, everyone else see that? All right, I wanted the segment. This is a SAS problem, not a Hills problem. And 50 is the hypotenuse. So I had to do 50 minus 40. So we got x equal to, what is that one, 20? Everyone's good? Okay, how about C? For C. Already drew, you're up. What do you got for your proportion?
25 over x equals x over 4.
Yep, and answer?
X equals
10, yep. That was a Hills problem there for C. All right, 3 more. Letter D. 3, new one here, Stellan.
12 over x equals x over 9.
Yep. 12 over x equals x over 9. We got a simplest radical form for me.
10. X equals 6 radical.
Got it. 6 radical 3. Good. All right, let's keep trucking. E. Two, 1, Norm.
16
Yep.
for x.
Equals.
X over 9.
You got it. Hill. I mean, that's a SAS one. And what'd you get for x?
12.
12. Good. Good work. Any issues so far? And then F. Let's finish this off strong before we go to the assignment. 2, Bailey.
144 over x equals x over 25.
Yep. And x equals
60.
60. Good. A couple things on the assignment tonight. You will have to factor on one of them. I won't tell you which one, but you will have to factor. Again, you're going to cross multiply, and it might look something like this. All right. So if you have an x squared and an x in the same equation, you can't square root. You got to factor. Set it equal to 0 and factor. All right. So just a heads up there on that. Okay. Check your work, please. Check your work on Classroom. New semester here.